First we'll go to this spec doc. This is a spec doc. Okay. This is a I2C controller IP. I2C controller IP. In this, see the features list. We have seen the features list already. Interface consisting of system interface consisting of this interface will act like a bridge between uh, uh, above controller and below above master and below slave. In between this one interface should be there. Okay, that is system interface. For this, we need to ensure that the all the signals connected to the interface were driving properly. That is our mandate. See here, deliverables. We'll have RTL code, RTL, TB test bench, simulation. After that, synthesis folder, doc, spec doc present in this. Okay. So here our features, it looks a little bit hectic to understand. So best thing is please go through the doc which is present here. That is nothing but feature compliance. Here features were given very neatly and clearly. See here the feature, how we will implement, who is the verifier, who verified. See, simply he mentioned it is so simple. We are making master mode as single master or multi master. If it is multi master, then there is a requirement of arbitration. Okay. Then slave mode either can be 7-bit addressing or 10-bit addressing. These two are real time possible. So we are ensuring that general call GC. Okay. General call, when we will use it, whenever we want to, yeah, when do we will use general call response means whenever we wanna external control should be controlled. At that time we will use general call. Slave transmitter receiver, each and every side, because we are interfacing here with slow and speed components at one side, like CPE, APB also bit speed only. APB to here, APB to I2C. I2C is bit slow. So to for without loss of any packet or a frame, what we will do is we will store in transmitter FIFO and receiver FIFO also. In transmitter FIFO, we will ensure that the whenever it is completed that transaction, then we will flush it out. That's how it will work. After that simultaneous master slave transaction should happen. Okay, uh, that we will ensure. Speed modes, we have different speeds. Okay, starting from 100 kbps to 5 kbps to 5 5 megabits per second. That much speeds were there, ultra high speed and fast mode. These things for these things we need to use clock divider. We will with the PLL we are designing a system clock. From that we are deriving clocks whichever we want for that specific speed. That's how it will work. Okay, and a controller may transmit to byte. This software means this is either firmware or software or OS or BIOS, all are same meaning only. First it will send a start byte. After that like a 01 HS code, which means high speed code. This is the specific code for that device ID, GC 10 bit, all these things. Okay, see, these are the features these people have given very detailed way. Other than going to the dark, if you go through once, you people can understand this. Okay, if you people get any doubt or difficulty, please you can approach to me. Okay, this is simple. In this, among them, which is more important is this DMA supports and a glitch also. Okay, HS mode support glitch filtering. What is meant by glitch? Glitch means unwanted noise generated in the channel between the one point to point communication. Due to the noise in the channel always noisy, so it will generate some kind of a noise. So while at the sampling the bit value or the receiver in the CDR block, clock data recovery block, we may get ambiguity due to either in place of 0 we may get 1, or in place of 1 we may get 0. That is what glitch. That glitch filtering is also present in our circuit. We ensure that glitch circuit. How to identify a glitch means glitch duration will be very very less compared to the pulse width, uh, uh, of compared to the t by 2. Okay, if t is 10 nanosecond, then t by 2 will be 5 nanosecond. Our this glitch would be around 1 to 1.5 nanosecond. That's it, the small duration. So filtering technique we will use it, we will extract that glitch, and so that we can sample the exact data. Okay, these are some speeds, these are some architectures things. Okay, see, this project mainly we are using for our indigenous project, that is open titan. In that open titan, BMS is the one of the, in that SOC BMS is the one of the subsystem. For that subsystem we are using I2C protocol to verify to get the information of the battery health checkups. Okay, whether all these are in the normal mode or going beyond the threshold values, that will ensure by the this I2C. Obviously I2C is simply a bus, two-wire bus. It won't ensure that controller DUT controller have a algorithms to identify that behavior, but it just will go and fetches the data and give it to the controller. That's all. It's as simple as that. Okay, so spec doc. See, interface we have discussed, system interface. Okay, controller are the host. This is nothing but master. Target are the slave. This is the end device. Okay. Frame type commands we will send it to FIFO. Okay. After that acquisition. ACQ means acquisition. This will hold the data bytes. Okay, for a specified amount of time. This S means start bit. SR means start bit repetition. Okay, and P means stop bit. You need to understand. Here we will have a register. Different types of accesses is possible. Uh, if you find anywhere, for example, RO, that means that it is read only. If you tries to overwrite it with the help of write test case. If you try to write it also, it will get a discard and will flag that I am read only. You can't write into my address like that. It will flag also. Okay. So and write only will also present wo. Okay, write only. So in that you cannot read, only you can write. RW means read and write. Both access will be. And here write one, read write one C. This is a specific thing, which means first it is reading, after that modifying it, writing back it. This is called atomic transfer. After atomic transfer, one time completion of that, it is clearing whatever it has written. In the meantime only receiver should fetch the data, otherwise it will get lose the data. First word fall through, this is nothing but FIFO only, simply. Okay. DXA OD, open train. Okay. Architecture, either CPU or DMA will be present here. Through AHP AXA bridge we will connect it to the APP interconnect. What is present in APP interconnect? APP interconnect present as decoders and muxes and arbitration algorithm. Of course, there are multi-master mode is also present. So it will be connected to the there here. This wrapper have a glue logic that is called core.v in your RTL code that will translate your APP transaction to the I2C transaction, and it will put it into the pins of SDA and SCL. That's all. That job is completed. So these are the actual top module. In that we'll get pad SCL, pad SDA. This will go into the bus, and whether it will the read operation, write operation uh, will taken care. See here I2C core. What are all present I2C core? See, command FIFO. FMT means command FIFO. Depth is 64, width is 13 bit. RX FIFO. This is the uh, six, all are 64 only depth, but we are varying the widths 8, 8, 11, 13 like that. Okay. Why it is? It's depend upon the how much data you are getting in a single transaction. Based on that, it will decide. Depth will be 64 only. Okay. The core controlled FSM, that is host side or master side. Slave FSM, two FSMs will be there. That you people need to go through. That is only your job actually. Okay. Bus memory and bus monitor, plus bus monitor will be continuously observing. If there is any error occurs, then it will recover, which means it will be either identifies, which means detects, or even corrects also. Okay. This is go to the mux will give to the input filter, that those are connected to the SCL and SDA things. Okay. See here, design hierarchy. Design hierarchy, what are all present? APP top, reg top. Yeah, here we have a set of registers. Those registers you people need to understand. You need not to by heart, you need not to remember anything. You need to understand if it is any register. Here all registers are 32 bit. So each bit are a set of bits. We call it as a field. If you configure according to that, it will behave. That's what hardware register configuration people will take care of it. But still, you need to have an idea on that. Core is a glue logic. I2C core contain a glue logic which will translates from APP world to the I2C world. Controlled FSM. Okay, this is master side FSM, target FSM, slave side FSM, bus monitor. It will simply uh, it will uh, it will be continuously monitoring and updating. Bus recovery, 9 pulses. Okay, plus a stop bus clear. Input filter. To these filters and all are used for synchronization as well as to ensure that the glitch free. These FIFOs, parameterizable synchronous FIFOs, these are 4 instances will be present. These are to store temporarily your data until and unless there is a communication will happen from one point to another point. See, there are code, architecture, everything in detail which given you people can go through. The clock and see only single clock domain here from the system and we are deriving from it. Open train interface. See, signal interface. See, always a clock and PRSTN. These two signals are inputs. This APB slave interface here. See, some signals I means input. These are O means outputs. I2C bus interface, SCL, SDA, these are inputs to this I2C I2C interface and a SCLO, SDAO output from that. Okay, same two lines would be input and output. It is working. That's why, but not simultaneously. A little bit more enhanced way than a simplex. It's called off duplex. Okay, interrupt and a DMA. So see, these are the DMA signals. You know, right? Interrupt will be the present under some registers, TX request, DMA receiver request, transmit request. So through transmitter request, it will tell that these many bytes of data in a descriptor. I'll write it. Read requested DMA will tell that I want this much of the payload need to be stored, uh, need to be get from outside the world. So controlled FSM and all. You people go through these FSMs and all. You people can understand very clearly. These are FIFOs. You are very much aware of FIFOs, right? Here also same. See, this functionality we have discussed. Okay. This whenever SCL should be high, SDA is transiting from low to high. Here, sorry, high to low. Then it is start bit. After that, data transfer will happen. Okay. D7 to D1 are address bits. After that, this B0 is nothing but read write. After that, acknowledgement. After that, stop. After that, again data will comes. Okay. These are the state mission. Don't get scared. Okay. Step by step, if you people will follow, then you people can understand. Okay. FIFO functionality, clock stretching explanation. We discussed already yesterday. Register map. See, I'll explain here. Any protocol for the sake will have set of registers. Those registers have offset address. That is nothing but a base address. We can call it as base address or offset address. Okay, that address, offset address or base address. This is interrupt states address is 00. So this is 32 bit, right? So 4 bytes it is taking 00, 01, 02, 03, 4 bytes. After that again each one is taking 4 bytes. See, here access type is given read only or read write once and clear. Okay, interrupt state like that. See here, read write or write only like this. That's it. You people need not to go through the every whenever you require on demand which register you need to configure out. At that time you need to go through spec doc to that particular register. You need to see the how it is defined based on where configuration of the values or fields or entire register value, it will act accordingly. Yeah, here register bit by bit explanation is given, so you people can go through. And we have ran also, right? Sorry, we have ran and checked also, that one. Mm. And we need to see here, we have 24 test cases, various task based test cases are present, that we need to run it and check it. I still I didn't get tiger vnc. Once we get, we'll run it and check it. After that I'll explain through waveforms as well as transcript. You need to understand each and every bit. Those 24 test cases, I'll run 4 or 5 test cases so that you people will get good confidence. Okay, any doubts? Any doubts in this? Hello? 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 Thank you, Srinidhi. Yeah, can we wind it up or okay? Have a great day. Bye. Thank you.